In this video, we're going to study subsets and supersets. Subsets and supersets. Given two sets A and B, A is a subset of B indicated by, in symbol, A is a subset of B if every element of A is also an element of B. By definition, if two sets are equal, then they are subsets of each other. It also follows that a set is a subset of itself. If A is a subset of B and A is not equal to B, then we say that A is a proper subset of B, or in symbol, A is a proper subset of B. If A is a subset of B, then it follows that B is a superset of A, indicated by, in symbol, B is a superset of A. The null set is a subset of every set, and every set is a subset of itself. Let's have example. Suppose, for example, we have set A containing the elements 0, 2, and 4. And we have set B containing the elements 0, 1, 2, 3, 4, and 5. Now, which of the two sets here is the subset? Okay, we have set A is a subset of set B. Okay, why? Okay, because every element of set A is also an element of set B. Let's check. 0 is an element of set A, it is also an element of set B. 2 in set A is also in set B. And 4 in set A is also in set B. Okay, now, but B here, B is not a subset of set A. Why? Because not all elements of set B are elements of set A. Like, for example, 1, 3, and 5. These are elements of set B, but not in set, that are not in set A. Okay, so since set A is a subset of set B, it follows that B is a superset of set A. Okay, so superset is used when you read or write from right going to left. So B is a superset of A. So when you read from left to right, A is a subset of B. Then from right to left, B is a superset of A. Now, since A is not equal to B, so we can conclude that A is a proper subset of set B. Okay, let's have another example. Suppose, for example, we have set C containing the elements 1, 2, 3, and 4. And we have set D containing the elements 2 and 3. Now, which of the two sets is the subset? Is it set C or set D? Okay, so we have set D is a subset of set C. Okay, why? Because every element of set D is also an element of set C. Let's check. 2 in set D is also in set C. And 3 in set D is also in set C. In other words, all the elements of set D are elements of set C. Therefore, D is a subset of C. But C is not a subset of set D because not all elements of set C are elements of set D. So like 1 and 4. These are elements of set C that are not in set D. Now, since D is a subset of set C, it follows that when we read from right to left, C is a superset of set D. Okay, and since set D is not equal to set C because of 1 and 4, these are elements of C that are not in D, so they are not equal. So D is not equal to set C. So we can conclude therefore that D is a proper subset of set C. Okay, so let's have another example. What if two sets are equal? Okay, so suppose, for example, we have set E containing the elements A, B, and C, and we have set F containing the elements C, A, and B. Okay, examine every element of set E and every element of set F. Are the two sets having the same elements? Okay, the two sets are having the same elements, so therefore the two sets are equal sets. Set E is equal to set F. Okay. Now every element of set E is also an element of set F, like A, B, and C. All these elements are also elements of set F, A, B, and C. And all the elements of set F, A, B, and C are also elements of set E, A, B, and C. Therefore, they are subsets of each other. So we have set E is a subset of set F, and set F is a subset of set E. And it follows that when we read from right to left, F is a superset of E, and here E is a superset of F. Okay, so what about a set itself? Okay, so like for example, set A containing the elements 2, 3, and 5. Now the reflection of a set is itself, say A containing the elements 2, 3, and 5. Now every element of a set is in itself. So 2 is in itself, 3 is in itself, 5 is in itself set A. So therefore A here is a subset of A. And it follows that A is, when we read from right to left, a superset of A. So in general, a set is a subset of itself. Okay, so what about a null set? Okay, uh, suppose we have three sets here, A, B, and C. And suppose we collect elements of these sets, so say 1, 3, and 5 elements of set A, and set B contains the elements A, C, and D, and set C contains the elements 1, A, B, 3, and 4. Okay, now when we collect elements of a given set, we start from nothing. So we start from an empty set, which has no element, right? We start from an empty set. So therefore, an empty set is contained in a given set. So therefore, since an empty set is contained in a given set, it is a subset of the given set. Say, for example, here, the null set is a subset of set A. Here, the null set is a subset of set B. And here, the null set is a subset of set C. So in general, a null set is a subset of every set. Now let's have more examples. Okay, let's try this. Okay, example. Given the following sets, set A containing the elements 1, 2, 3, set B containing the elements 1, 2, 3, set C containing the elements 1, 2, 3, 4, 5, and set D containing the elements 0, 1, 2, 3, 4, 5, and 6. We can conclude the following relationships. Number one, that A is a subset of set B. Okay, why? Okay, so we can see here that every element of set A is also an element of set B, right? So we have 1 in A is also in B, 2 in A is also in B, and 3 in A is also in B. Now, in fact, these two sets are equal. A is equal to set B. And since the two sets are equal, we can add more relationship. Okay, that set B is also a subset of set A. And it follows that when we read from right to left, B is a superset of A. Now, since here B is a subset of A, follows that A is a superset of set B. Okay, so let's go to number 2. Number 2, A is not a proper subset of set B. Okay, why? A is not a proper subset of set B because A is equal to set B, right? Okay, number 3. B is a proper subset of set D. Okay, for 2 reasons. First is because B is a subset of set D, and set B is not equal to set D, right? Okay. Okay, so observe that every element or all the elements of set B, 1, 2, 3, are elements of set D, 1, 2, 3, right? So we have B is a subset of set D. Okay, number 4. We have D is a proper superset of set C. Okay, so if we read or write this notation from right going to left, it follows that C is a proper subset of set D. Okay, now why is it that C is a proper subset of set D? There are 2 reasons. First, C is a subset of set D, and second, C is not equal to set D. Okay, let's check if set C is a subset of set D. If all the elements of set C are also elements of set D. So we have here all the elements of set C, 1, 2, 3, 4, and 5. Let us check if these elements are also elements of set D. We have 1, 2, 3, 4, and 5. Okay, every element of set C is also an element of set D. So therefore, set C is a subset of set D. And set C is not equal to set D because there are elements of set D that are not in set C, like 6, right? So since C is not equal to set D, therefore, C is a proper subset of set D, and D, it follows that D is a proper superset of set C.